Okay, just to answer a question that will get asked if I don't say this, all of the enhancement that you heard from both Peter and Harriet that relates to Luster going forward and object-based SAM QFS going forward are going to apply to the storage solution I'm talking about here. Okay, that's all the stuff that we were going to talk about at this conference. That's what I'm going to talk about there, storage and retrieval. And we're going to say, what am I really trying to do here? You can read the words as well as I can, but the real thing that we tried to deliver here is recognize that historically in the past, Sun has walked up and said, here's all this great stuff. I have 3 different kinds of file systems, 14 choices of servers, and 17 networks, and 43 NIC cards, and 9 sets of rack rails that you can't figure out which one to buy. However, if you would like to buy all that stuff and put it together yourself, let us know how it worked, the Lego toy approach. That's unacceptable in today's business. So we realized that we needed to sit down and develop a solution that is probably appropriate for 90% of the HPC space. It's probably not appropriate for Blue Gene. It's not appropriate for TAC at the really bleeding edge, very high end. But for the other 90% of you, how can I deliver tested, functional, integrated solutions that have been put together? We have run performance testing on them so you can expect to know going in what the latency, IOs per second, and bandwidth based upon capacity you're going to get out, and dramatically reduce the time to deploy the stuff and reduce the risk of having to redo it over and over again. So that was the going in thing we decided we really wanted to do here. At the second time, we said, and then I'm going to show you the first implementation with real numbers of what Peter brought up of open storage, which is how we are going to manage our disk archive out here. At the end of the day, and we have long white papers that show you these numbers compared to other solutions, not only using other Sun components, but some of our competitors' components out there, how you can dramatically knock down your total cost of ownership and acquisition cost over time. Why do you care? Well, everybody comes in and said, well, if I can save the money on storage, then I can buy more compute nodes, and that's what I want to do. Now, of course, as a storage guy, I think you ought to do it the other way around, but I lose that argument. But at the end of the day, we want to show you how to save money. Harriet talked about community enhancements. We want to show you how you can grow from 1 gigabyte to 100 gigabytes per second bandwidth without changing the architecture, and do that without either completely reformatting, moving, or migrating your data at great cost. And the final one is give you a complete choice of selection so you can enter the system at whatever size you need. Grow it, shrink it, scale it, and protect the investment of all the hardware, and most importantly, software implementation that you've already done, okay? So this is the 3 reference architectures we're going to talk about. We defined what we call the baby system, or the core. Think of that, that's good to maybe up to a gigabyte per second bandwidth, but it has all of the data management function that Harriet mentioned. For instance, the ability to have your shared clustered file system, to driving into moderate-sized grids, a seamless global namespace that incorporates home directories, Scratch, and archive with policy-based or on-demand automatic data management between all of those. So no data copy, okay? All built together. Now you want to go a little faster, you add the yellow component on here, and I scale this thing up to 2 to 4 gigabytes per second without changing a single piece of architecture, moving any data back and forth, or doing anything unusual. And I can scale independently Scratch bandwidth, latency on Scratch bandwidth, the type of networking you use to hook it up, the amount of disk archive, disk cache, and long-term take archive, and do those all independently of each other, because quite frankly, your storage requirements are going to be different based upon the applications that you're trying to run. And then if you come up and say, hey, I really want to do that 100 gigabyte per second thing, I want to seamlessly bolt this into the Luster file system as it exists today, but most importantly, as Peter mentioned, as it will exist tomorrow, which will eliminate the requirement for having data movers that will go between think of it as the Luster side of the house and the SAM QFS archive side of the house, which we have to do today. So I want to restore that seamless global namespace bridge. And Sherry had already showed you that picture, so we can skip it. So here's the challenge we face going in. Half of you say, I want high capacity because that is crucial. You said, oh, by the way, I want to go like a bat out of hell. I want a single architecture and run multiple workloads against it, and I don't want to pay you very much money for all of this, at least on a $1 per gigabyte basis. It's really hard to build something that meets all of those requirements. You want to go really fast, I go, that's terrific, but it's called checkbook scalability. Give me some money. If you want a hell of a lot of capacity, not a problem, buy some more storage. That will cost you money. So I had to try to match all of these things, and I think we've done a fairly good job of doing that. How do we do that? Well, I'm going to start with the base of SAM QFS. You all know what that is, but the key part here is, under policy, we will dynamically move the data, either explicitly through libsam APIs or by attributes and policies you set to the most appropriate media. That media could be tape, that media could be extraordinarily dense serial ATA, and as I'm going to show you in a couple of slides, that media can be basically one of our storage server components that will take advantage of the zpools component of ZFS to provide software RAID and eliminate the extraordinarily overpriced RAID controllers that you're paying for today. By the way, one of the things, for those of you who go to AMD, probably in the lecture they will tell you that 99% of the cost of building any microprocessor is incurred prior to manufacturing the first one. Therefore, you better make a whole hell of a lot of them, millions and millions. Well, if you only make 5,000 RAID controllers, that's not a lot to amortize that cost of unique ASICs across it. Now you know why they're so expensive compared to commodity products. Some of the things we forget, particularly for those of you who may not be all the way tied into the InfiniBand space, is Sun makes some of the most amazing NIC cards in the industry. We've basically taken levels 1 through 4 of the IP stack, put them out on unique Sun-developed ASICs right out on the NIC card, so all the packet classification, reordering, and ring buffer management, for instance, along with TCP checksum validation, takes place in the NIC card and not in your memory. And if you've ever looked at packet reordering, it's like playing 52-card pickup. Throw all the cards on the floor, you got to pick them up and put them back in the right order. You really don't want to do that, particularly in your client. You want to be computing your problem. So this just took that right out of your memory stack and reduced your memory interrupts and cycles just by using intelligent design to network it together. All right, architecture overview, we're going to go really fast here. We mentioned there's a common core data management module that comes with all systems, and it's really the brain. It's where we have implemented a highly available SAM QFS cluster, which manages all the automated data movement between disk archive, disk cache, scratch, home directory, however you want to call it, long-term tape archive, and most importantly, automatically protects the data under policy every time I create or change an object. If you think for 1 minute, if I have 2 petabytes worth of data and I'd actually like to back it up, forget it. How should I protect data? Obviously, when created or when modified, it's just a continuous process. The system provides that. It'll do it locally and remotely. We have what's called a data access module. So if I want to add more horsepower, AKA bandwidth coming out of this thing, I scale those horizontally to get to whatever the appropriate performance you need is. Under today's networking, I'll use 10 gig E as an example, each data access module will deliver approximately 400 megabytes per second worth of bandwidth. So if you happen to need 2 gigabytes a second, do the math. Now you know how many of those you're going to need. We have something we call the online storage module. High performance, low latency disk, typically used for Scratch. Typically used for Scratch, but it doesn't have to be, and that's just a piece I can scale. We have a disk and tape archive module. The big thing on the disk module is probably the first implementation of a tested configuration using open storage. Interestingly, as I mentioned, what we do is we happen to take an X4500, that's our Thumper product today, 2 processors, 48 terabytes of serial ATA. I run 2 key component software on it. One is the DMU to give me the pooling and data management and RAID protection, including all of the checksumming and transactional basis provided by the ZFS stack. And I run a product called SAM Remote. directly on top of that. That just makes it a seamless part of my multi-tiered archive, and we move the data in and out, fully protected, fully checksummed, always available in a global namespace to the application, out of the box, no hardware RAID controllers necessary. Now you can look at me and say, well, today's X4500 is a single point of failure if I ice pick the controller card, and that's true. Why do you think we have continuous data protection and write a second copy to tape? Because if it blows up, we'll just go out and get the next best copy and give it to you. So the application and you don't stop running, you just keep going, and we took the concept of backup and restore out of the lexicon and introduced the concept of continuous availability. And of course, the scalable, what we call the scalable storage cluster, read Luster cluster addition for those of you who really want to crank the speed up into the tens to hundreds of gigabytes per second. That's what your entry-level system looks like. Typically those in what we model were X4500 servers for the core data management module, and in the entry baby one, they provide my IP access into your grid. You have multiple choices of tape scaling from an SL500. It could be 60 terabytes up to thousands and thousands and thousands of terabytes. Down in the middle is your disk archive module. I'm just showing two of them here. It could be 10 or 100, depends what you need. And again, delivering you that incredible density and price performance because we're leveraging open storage. And then over on the left-hand side is basically what we call the online storage module, which typically I would use for very low latency and bandwidth sensitized scratch. Yes, that's where I'm using hardware RAID because I want the ultimate performance and the ultimate failover. So I'm mixing the right stuff based on the workload. Medium, I cracked it up, and you notice I added more data access modules. Those are QFS data movers. And it's a typical 1U, 2U thin server. We use an X4100 in the example we do. If you throw a 10 gig wire at it, off-the-shelf components from Sun today, it'll run at about 400 megabytes a second. If you have big, heavy sequential, I can get a little higher. If you got shorter records, a little more bursty, I'll run a little lower. Where does this end up at the end of this year? And this gets interesting. Suddenly that becomes ICER over InfiniBand. And you start getting a gigabyte a second out of every one of those things. How do you get from here to there other than the software upgrade? Well, you take the NIC card out and you replace it with an IB NIC. And you do that in the other end of the thing. Everything else in the thing stays the same, data stays in place. Really a nice system. And you say, well, hell, that's not enough. Let's bolt them together. And this is really the architecture developed at TAC. Those boxes connecting the SAN and the InfiniBand network are the data movers. That is a QFS client and a Luster client looking directly at each other. So my data transfer bus is main memory. And main memory has got a pretty good bandwidth, like lots and lots of gigabytes per second. So how fast can I move data back and forth? Well, you tell me how you want to stripe it, and I'll move it at hundreds and hundreds of megabytes per second in and out of the Scratch file system. That's what the core management module looks like. There's the online storage module. This is where it's very interesting. We give you a plethora of striping options based on your workload, and you can use more than one of these based on how you do the file system. Everyone knows standard striping. I take a large record, chunk it up in a lot of pieces, write it out in parallel. Really great for single thread, really stinks for a whole lot of short record I/O. Round robin, first record here, second there, third there, really nice for shorter stuff, not so good for great big stuff. So let's do what we call striped groups, or two-level striping, and this is where I think we're really unique. I can take a standard stripe and I can write it to a secondary level stripe, which basically multiplies the bandwidth. So if I have unbelievable bandwidth requirements, I can build the right stripe set for that, and that's typically for single or few applications that are reading very, very large records and lots of them. Or I can do what I call the best of both worlds. I can do round-robin stripes to stripe groups, which means the first file gets written, say, to a stripe of 50 disks or 10 disks, the second file to the same, and the third file to the same. And as Harriet mentioned, we can set these up in pools because I'm probably going to stripe my Scratch stuff a little bit differently than home directory. I am certainly going to do that differently than I want to do in my disk archive. so we can balance the system to the workload and the type of hardware and disk that you're buying today and tomorrow. Storage access model, this is a horizontal scale. You buy 1, you buy 10, all it does is it adds bandwidth as it goes out. Disk archive module, I already mentioned the key thing here is we're leveraging the whole concept of open storage to get you down well below that $1 a gigabyte line for disk-based storage. Historically, people have had to play with tape to get down there. Tape archive module, pick your poison, up to 300,000 slots. Any kind of tape drive you want. If you're an LTO bigot, great. You like 9840Ds, go ahead and buy them. Like T10Ks, buy them all. I really don't care. All they are is targets. The key thing here is we manage the space for you, including recycling and defragging the tape libraries and using them for your protection copy. So goodbye database administrator, backup administrator, restore and all of that. The system ought to just do it for you and you can focus on your workload. We've already talked about this. This is Luster today and Luster tomorrow. As we introduce the object support of InfiniBand, now you can have a seamless network as it becomes integrated in Luster 2.0 and down the road, that the whole thing can be on InfiniBand, or it could all be on 10 gig E. It could be on a mixture of both. I really don't care. We want you to have the choice based on your workload. So go faster now. That's what we're trying to tell you. We will have white papers out in about 2 weeks, and most importantly, what we call the sizing guide, which will be based upon extensive analysis in our lab, so you'll know exactly the bandwidth based on different I/O characteristics you'll get by network attached and by capacity. Done, thank you. Time for a break.
Thank you very much, Chris. Wait. You're not off the hook yet. Any questions?